Balvikan Bharti with your mentor Avila Sarkar. As I shown you the finding of your uh, inverse matrix with the method of determinant and the elementary transformation method. So both we have seen. So we have given one example. Now we are bringing one or two more example. There will see how the things are moving, and is there any other operation then we can try in that to find the solution. So uh, let me take the whole board so that it would be helpful for me, and the matrix that I will take, writing it direct, 1 2 3 1 2 3 2 5 7 2 5 7 minus 2 minus 4 minus 5 minus 2 minus 4 minus 5 minus 4 minus 5. Okay, so now this also can be represented for a notation, because what I am doing, A is equal to I into A. So we are doing operation to this. Now if I can keep this side by side, because I am not doing anything to this, so I am doing to this. So for easy notation I am making a boundary here and putting the unit matrix side by side. Okay, so that both the operation can be done simultaneously without moving my pen or my mind separately by this. So whatever operation I will do, I will write it here. Okay, so let be the first operation. Now here I will try one operation, that is switching the row. So that means I am switching row between R2 and R1. So that is my first operation. This is one kind of operation also can be done. So only thing is your restriction, you have to do operation either by rows or the column. That is the first restriction. Otherwise you can do whatever you want to do, but operation must be of row and column. No diagonal or any other direction is possible. But if you start with the row operation, you have to end with the row operation only. That is the most important thing. So now if I switch it, so what would my case? So 2 will go there. I am just writing the term first, then I will rub it. This will be 7 and this will become 1, this will become 2 and this will become 3. So my thing will change into this, and this will be 1, this will be 2 and this will be 3. So this way I am just changing. So let me write the exact matrix here so that I should not forget it later. 1 2 3, then 2 5 7, and then minus 2. I need it later on also, because what I am going to do this time, I will calculate the inverse of matrix with both the methods, and then I will see whether the results are same or not. So that is very important. You have to get the same result both the way. So then already this is successful learning. So first thing I did, R1 replaced. So what else we can do? So let me write it perfectly one after another. This now my target is to now this also has to be changed. So this will become 0 1 0, this is 1 0 0. So, okay, my second operation could be what? You tell me. I have to eliminate this part, this only this has to be in 1. So I have to try to eliminate this to 0. So the first target is possible to make it 0 if I multiply this 2 with 2 and deduct from this R1. So this could be R2 become R2 minus 2 into R1. let me do it. Okay, if I do it, no sorry, 2 into r1, 2 into r2 into minus r1. So I multiply this 2 and then deduct from all the reverse one, because r1 is higher, so r1 minus 2r2 I will do, and that will be placed in r2. This is the changed location where I will do this operation. So r1 I will deduct here by multiplying this 2, and so this if I multiply the 2, it become 2. So 2 minus 2, this will become 0. The first is eliminated. This I multiplied by 2 is 4. 5 minus 2, this will become 1. So this 2 at once it has came. Now this 7 minus 2 multiply, this will become 6. 7 minus 6 is equal to 1. So this is okay, successful, because these two terms are able to bring it in form. So my next is this one. This you can see, if I add these two, I will get 0. So this can be possible. So the next operation is R3. I will bring it by R3 plus R1. So if I do this, R3 is minus 2 plus 2, this will become 0. This 5 minus 4, this will become 1. 5 minus 5, this is equal to 2. So just reduce. Fine. So slowly it is coming to the way. So now this also can be done, this and this. Now the fourth operation, if I do R1 become R1 by 2, and the simultaneously R3, if I do R3 by 2, both operation I do. So to get R1 by 2, this will become 1. So I can able to convert the diagonals of this 2 by this. This if I do, I need not to worry about all other things. My target has to bring this. So this is 2. Now further what I am doing, R3 by 2. So by 2 is equal to 0. This is become half. This is become 1. So diagonal become 1. So target is filled. Next target is each row I have to bring 2 zeros. So that has to be there in my next target. So then it will be easier. So bring 2 zeros is already 1 0. There is one other 0. So if I deduct R2 minus R3 in my next operation, okay, I am not able to do it simultaneously. So we have to do all this. That's why I am writing. So I will do it later on. So let me bring it first. So by that time you just forget it. I am not done all this operation. Only thing I have done the first operation. Okay. So the from next operation I will follow this also. Okay. So let it be like that. Or you can do simultaneously. Don't forget to do it. So later you have to do it separately, or else I can do it later on. So now concentrate on this R2. If I want to bring 0 here, so this is R2 minus, if I do R3, so this becomes 0. So what 0 minus 0 0, 1 minus half, it will become half, because R2 I am changing. 1 minus 1, that will become 0. So this is another operation I did. Now the next target is to bring this 0. Now this 0 means you have to deduct again. Sixth operation, R3 can be now done by R3 minus R2. If I do this, now this time 0 R3 I am changing from by deducting R3 from R2, R2 from R3. So 0 minus 0 0. This minus this is become this equal to 0. This minus this equal to 1. So this will not change. So 2 I have already got. So what else I have to do? Yes. Now the seventh operation that I can do, I can change R1 by multiplying 7 by 2 with R3, and I can deduct R1 minus 7 by 2 from R3. if I do this, then what will happen? This I am multiplying with r by 2. So this is 0. R1 minus 0 is, this will not change. This also I am multiplying with 7 by 2. It won't change. So this will remain. What would change in there? R by 2. 7 by 2 if I multiply, this will become 7 by 2 and deduct from R2. So this will become 0. Okay. My next operation will be multiplying this with now this has to be brought to 0. So my next operation is R1. I can make R1 minus 5 into R2. So I am multiplying this R2 with 5 and deducting from this. So this will 5 is 0. This will not change. This is why I multiply with 5. This will 5 by 2. So this will become 0. This is 0. So this is won't change. Then last operation that I will do, I will multiply R2 with 2 of R2. So this, if I multiply the 2, this will become 1 and other things will remain same. So these are the operation. This could be any other operation. This you can try your own, and you can this is also possible, you can make it in 4 step also. Whatever I did, this is not the unique way of doing this. This could be done in any other operation, and that there needs your practice and your expertise. More you practice, more you can see different way of doing that. Okay, so now this all operation I have to imply on this. So first I have this, I have already switched this, I did. Second is R2 is equal to R1 minus 2 R2. So if I multiply with 2 this one and I deduct from R1 and putting it in R2. So there I will put, so 2 into R2, from R1 I am deducting. So 0 minus 2, this will become minus 2. R2 0, this won't change. Then R1 minus 2 are 0, so this will become 1. 0 won't change. So this I already did. Third one, R1, R3 is equal to R3 plus R1. R3 is equal to R3 plus R1. So this 0 plus 0 won't change. 1 plus 0, it will become 1. 0 plus 1 is equal to 1. So this also did. Okay. R1 is equal to R1 by 2. R1 become R1 by 2. This will only change. And R3 is equal to R3 by 2. R3 by 2, that means this will change. This will change. Okay. So this also did. R2 is equal to R2 minus R3. R2 is equal to R2 minus R3. So I have to deduct and put it in R2. So this will change. R2 minus R3, this will not change. 1 R2 minus R3, this will become half. R2 minus R3, this will become minus half. Okay. This done. Fourth, R3 is equal to R3 minus R2. R3 is equal to R3 minus R2. This I am deducting, so this will become 2. R3 minus R2, this will become 0. R3 minus R2, this will become 1. This is done. R1 is equal to R1 minus 7 by 2 of R3. So this is in between R3 and R2. So R1 is equal to R1 minus 7 by 2 of this, needs some calculation, 0 minus 2 into 7 by 2, and this will become minus 7 here, half. The next one is half, minus 7 by 2, this will not change. 0 minus 7 by 2 of R3, 1. So this will become 7 minus 7 by 2, minus 7 by 2. Okay. This change done. R3, R1 is equal to R1 minus. So again R1 is changing with respect to the R2. So this is minus 7 minus 5 into minus 2. So that is equal to 10. 7 minus plus 10 is equal to 3. Where it is coming in place of R1. So this is 3. This again half R1 minus 5 into R2 and 5 by 2. This will become 4 minus 4 by 2, that is equal to minus 2. This will become minus 2. And the last one is minus 7 by 2, that is R2 minus 5 into R2 is equal to minus half, that is equal to plus 5 by 2. So that is equal to 2 by 2. Minus 2 by 2 is minus 1. So this will become minus 1. Okay, this is done. Last one is R2 by R2 is equal to 2R1. So I have to multiply it with 2. So this will become 4. This will become 1. This will become minus 1. So the my last transpose will be inverse will be this matrix 3, this one, and 2, 0, 1. Sorry. So I will rub it out. So this all done. After that I got this value. So I am writing this inverse value here. A inverse by the method of elementary transformation method. So my ultimate inverse is this one, minus 4, 1, minus 1, 2, 0, 1. Okay, now we'll find the same inverse value of this matrix by determinant method. Now find the determinant first. So determinant will become 5 into 5, 25, minus this will come as minus 28. This is first, minus second element 2, alternatively minus plus minus plus, and this will come as this 5 into 2, that is equal to minus 10, minus of minus 14. Okay, this will end the bracket here. Okay, this is this and this. So this and this. Okay, the last one is 3, and the thing will allow minus 8, minus 10. So this will be my determinant. So if I calculate this will be 25 plus 28, that means equal to 53, minus this will be 14, plus 14 minus 10 4, 8, plus this is 10 2, 6. So this all total will become how much? This is 2 will be deducted only 51. So determinant of this matrix will become 51. Remember this. Now I will get the C or the cofactor matrix. Now cofactor matrix is that 5 into 5, this is become 53. 53 will come first position. This become this into this is equal to minus 10, 14, 4. This will be 4, minus 10 plus 14, and this minus 8 plus 10, 2. 25. Sorry, this is not that. 25 minus what I calculated there, that was 25 minus, so this not be the case. 25 minus 28, while calculating the first term it is minus 25 plus 28, 3. The value of this will be 3 minus 8 plus 6, so that is equal to 1. Sorry. Okay, the determined value was 1. I calculated wrong. The first term was minus 25 plus 28, so that is equal to 3 into 1, so that's equal to 3, and other things is same. So determinant value is 1. Just remember this. So this will be 1. So this is gone, this first row. Second row, first element, this and this will go. So 5 into 2 minus 10, and this is equal to minus 12 plus 12. So this is equal to 2. Second one, this and this. This become 1 into 5 minus 5 plus 6, 1. The last one, this and this is equal to minus 4 minus plus 4, 0. The next one is this one, this and this. This is 7. The value is 7, isn't it? Let me take this. Value is 7. So 2 into 7, 14 minus 15 minus 1. The second one, this one is equal to 7 minus 6, 1. The last one is equal to 5 minus 4, that is equal to 1. Okay, so this is the case. So 1, 2, 3. So this is, and I'm writing 1, 2, 3, 2, 5, 7, 2, 5, 7, and minus 2, minus 4, minus 5. So this was the matrix, and according to cofactor matrix will be, now I will assign the sign. The sign is plus, minus, plus, minus, plus, minus. So 0 doesn't have any meaning. Plus, minus, plus. So this will be the change with the according to the cofactor matrix and with the position sign. So this is, now I will take the transpose of this cofactor matrix. Now this will turn into 1 minus 4 2 minus 2 1 0 minus 1 minus 1 1. So this will be the transpose. That means it is adjoint of the matrix A. Okay. Now if it is adjoint of matrix A, so now your A inverse will be 1 by this, 1 by 1 means 1, and the matrix is become adjoint is 1 minus 2 minus 1 minus 4 1 minus 1 2 0 1. Now this and this must be same. So by seeing it, I cannot say these are same, isn't it? Can I say there one term is missing? It is coming as, how come it is 3? The cofactor of this is equal to, sorry, I made a mistake. This will be 3, sorry. Because this one, 5 into 5, this is equal to minus 25, minus of 4 into 7, this is minus 28. So this becomes minus 25 plus 28, so that becomes 3. So 3 will be the case of this cofactor matrix, and that sign will not change. So the after the transformation, this will become 3. Transformation, this will remain in same position. So now see, the both the matrix has become same. Understood? So I can now can say, if you adopt any of the method, either the transformation method or determinant method, you will get the same answer. That was my intention to prove, and you can try at home with any other example, and you can clarify whether these are coming same. Then you can get more confidence that you are in the, you are correcting, you are making it correct where the both the methods. Because the first method of determinant is very straightforward, very easy to calculate, while the transformation method needs more of the expertise. So you more you practice, you can. And one thing I will add to this, what is the use of this inverse in a practical sense? Now initially I told that any linear equation, if it is more of the variables are there to get the unknown, to get the unknown, the value of the unknowns, you have to do so many of means you can say elimination method or any other method, comparing method or elimination method, to get the unknown values. Now with the matrix it can be done easily, while this inverse is useful. Now let me take some practical example. 2x plus 3y minus z is equal to, let's say, 6. Another equation is 5x minus y plus 2z is equal to 7, and x plus 2y and minus 4z, let's say this is equal to 10. If these are the equation and arbitrarily taken, so this can be represented in a matrix form, where this is 2, 3 and minus 1. The value, the coefficient I am taking in one matrix, and accordingly, as this is coming before the variable, so I am writing the matrix before the value, before the unknown values. So this is 5 minus 1, 2, and this is 1, 2 and 4. And now this will where I will put x, y, z. Okay, so why that is kept there like this, why not kept like that? Because this is 3 cross 3 and this is how much, 3 cross 1. So for getting product, the rule is that the number of column for the first matrix has to be the number of rows in the second matrix. So if I put like that, I will not get this value. So the arrangement must be same, where the interior numbers has to be same. So number of columns here, number of rows here. So now this, when I will get the result, I will get in this form, because my formation will be 3 cross 1. The, as you know, when you do product, your result is 3 cross 1. So 3 is when number of rows is 3 and the column is 1. So you definitely will get the values like that, and this will be equalized to this. Now to get xyz individual value, I need to have something xyz this side and other things other side. So now if I can think, this is A. Now this is A into matrix of x, y, z, where I will get another matrix. Let's say here this is 6, 7 and 10. Okay, now if I multiply it with its inverse, literally I keep inverse. Okay, so now A is 3 cross 3, this must be of 3 cross 3 vectors, so inverse. So now this together will make it identity matrix, and this will be multiplied with x, y and z matrix, and there remaining thing will be there. This you can calculate by the method of adjoining or any other method you like, you can calculate. Now this, if I multiplied with 3 cross 3 vectors, this is 3 cross 1. Okay, now this has to be placed before than this, so this will come. If you have to multiply, you have to bring it before, because this is 3 cross 3, this has to be 3 cross 1. So now the column and row has to be same, so you have to multiply A inverse with this. Okay, now in this case also you can put anywhere you like, because if you put A inverse, this is 3 cross 3 matrix, this will give you the result, same result, because we know A cross B matrix, if it is giving identity, so either A could be the inverse of this or B could be the inverse of this anyway. So you can put any of this. So if you want to get this inverse, if you put like this, so you will get a identity matrix at the end. So this, if I multiply A inverse on the both sides, so this will turn into identity matrix and this will remain as it is, and you will get some other matrix, let's say B, of order what, 3 cross 1. So when you multiply with the this 3 cross 3 into 3 cross 1, you will get, it won't change any value, this will not impact this, this will remain as 3 cross 1 matrix. Here I will get 3 cross 1 matrix. Now see, x will be the value what we will get here. So this must be some value A, B, C kind of thing I will get in this ultimate matrix when you will calculate this. So you will get this one. So X can be compared as directly this value, Y can be compared with this value, and Z can be compared with C value. So we will able to solve in one shot. Okay, so this is the implication of this kind of operation. So that I will also show with a real example. This is just for explanation I did. I will give you some example, real example, where you can solve linear equation by this method. So thank you for now.